Lesson 16.8, initial value graphically. It's guided, and this is level 2. So now, going back over this stuff and kind of reteaching myself all this stuff on Delta Math, I found their videos very confusing. I'm going to simplify this as much as I can that makes sense in my brain. So because all of these graphs are the derivative graphs, that means these are rates of change or slope. So let's think of things in real life that would have different slopes. So let's think of stock market, or like you're investing your money and how much interest it's gaining and losing. Or if you got something in a pool, water in a pool, and the water's changing, rising and dropping with evaporation and rain. All that kind of stuff is great, but we don't know the final amount of water or money unless we know what it started with. Right? So if I'm telling you, hey, the stock market, my money gained $10 this week and lost $50 the next, that's great. I don't know how much money I have in it unless I knew what it started with. And so this initial value stuff that we're going to do in the next lessons is all saying, I'm starting with this, then apply the rate of change. So simple, but yet they make it so complicated. Okay, so we've got graph of f prime down here is shown. And they're giving us an initial value right here. This tells us what our money, what our water level, whatever you want to think in your head, what it started at. -3, -5. Then we're going to apply the rates of change to find what these points would all be at. So again, taking a derivative graph, plotting actually the original. So what I would like to do, I'll make it kind of down here, is make a table. Put x, and then I'll put f of x, what the original was. We're going to put all of these x values that they want us to find. And put the initial value they give you, -3, -5. And let's go ahead and plot that. So you see all these shaded lines? That's because you should have a point on every vertical that's shaded. -3, -5 is here. Okay, so then on theirs, they'll allow you, this is yellow, you can drag this. It kind of helps you a little bit. To me, I don't know, I don't really need it. But anyway, so then let's go forward. I'm not going to go backwards yet. Let's go forward. So we're finding the interval -3 to -1. -3 to -1. I want the area of this triangle. That is 2 by 2 triangle. So that's 4 divided by 2 is 2. So we need to have that this initial value has a rate of change of +2. So -5 plus 2 will now put us at -3. So put a point at -1, -3. All right, now we're going from -1 to x is +1, which is here. Oh, I need to actually back up. That area was below, so that's negative. Sorry. So -5, it's like my money or lost money. -5 minus 2 would be -7. Let's move. There. Okay. -1 to 1. Now we're positive. So we've got a 1, 2 by 2. So again, that's 4 divided by 2 is 2. And we're going to add. So -7 plus 2 puts me back at -5. Okay, then going from 1 to 5 would be this triangle. That's 4 times 2 is 8. Half of 8 is 4. And it's positive, so I'm going to add 4 to -5. That's -1. And then going from 5 to 9, I'm back to being below the x-axis. That is 4 by 2 is 8. Half of 8 is 4, so I'm going to subtract 4. -1 minus 4 is back to -5. It's kind of going back and forth. Okay, now here's kind of the tricky part. Oh, sorry, I'm not even on the graph. Here's kind of the tricky part. We gotta go backwards. Okay, so if I want to find from -3 to -9, it's kind of like thinking of my bounds being backwards, so it's the opposite. But how I really like to think about it is still go from -9 to -3, which happens to be a rectangle. It's 6 times 2, that's 12, and it's negative. So I know that from -9 to -3, it had to go down by 12. So it kind of becomes an algebra problem of what number that when I subtract 12 gets me -5. Well, I actually have to do the opposite operation, which is add 12. So when I want to go backwards, I'm doing -5 plus 12 in my head, which should have been 7. And then you could just check. Is 7 minus 12 get you -5? Yeah. -5 minus 2 is -7. -7 plus 2 is -5. You can kind of just see that it works. So I need to plot that at -9. It actually was at 7. And it'll make a curve for you once you're all done. Like that. Let's try one more to make sure we really understand. And this time, we got some of the similar values, but some that are different. So let's make a table. Put in all the x values. And it wants to know what were the y values of this original function. Well, they give us that when x is 4, y is -3. So that gives us a starting point. I'm going to have to find the points, and I picked this one in particular because I'm going to work backwards a lot. Only one time do I actually get to do the normal thing. Okay, so then let's plot that point for -3. And we got to find some area. Let's go from 4 to 9. That's a rectangle, and it's positive. So that would be 5 times 2 is 10. We're going to add 10 to our initial value. That would be 7. All right, now I got to work backwards. Let's think 3 to 4. 3, 4 is this itty bitty triangle. That's 1 times 2 is 2. Half of 2 is 1, and it's positive. So when I go from 3 to 4, I got to add 1. When I work backwards, I'm going to go -3 minus 1 was actually -4. Okay, let's go 1 to 3. 1 to 3. That's going to be a negative something. That is 3 times 2 is 6. No. Oh, that goes down to 4, sorry. 4 times 2 is 8. Half of 8 is 4. So I'm subtracting 4, but -4 really plus 4 is 0. So that when I do 0 minus 4 gets me -4. It's getting a little bit off, sorry. Okay, -2 to 1 is this triangle, which is 1, 2, 3 by 1, 2, 3, 4. That's 12. That would be 6. -6. But I'm going to do 0 plus 6, so it was 6. Okay, -5 to -2. That's 1, 2, 3 by 1, 2, 3, 4. 12, that's 6. So I've got to have plus 6 here. So I'm going to go 6 minus 6 is putting me back at 0. Kind of makes sense. These areas cancel each other out. Go -7 to 5. -5, sorry. That's 2 times 4 is 8. Half of 8 is 4. I'm going to 0 minus 4 is -4. And then from -9 to -7, that's 1, 2, 3, 4 times 2 is 8. That's 4. -4 plus 4 was 0. So again, it makes sense because these two cancel each other out. So then you would just plot the points over here, and it'll make the curve for you. And I do want you to see the connection that when my area is negative, see how this function was originally decreasing. So because this was decreasing, the velocities were negative. When I'm positive slope here, I should be above the x-axis. So all of that stuff should make sense.